way back at the start of our text, chapter page 5 or 6, we first were introduced to the concept of sampling. And samples versus populations. Okay, we are introduced in the sense of one of the branches of statistics is that of inferential statistics. And with just a brief mention of samples and populations, we largely set that aside. We turned our attention to descriptive statistics, then we turned to probabilities. And now here in Chapter 8, where are we? Chapter 8, we're turning back to sampling and inferential statistics. So we're going to spend a number of chapters here now talking about how can we learn things from samples and apply it to populations. Okay, and so as we do that, I think that's important to remember that the whole goal of this inferential statistics area and all of the sampling and applying normal distributions and going through all the z-score calculations, all of this is with the intention of learning something about the population. And so there's going to be different kind of problems we come across along the way, and those are going to require different kind of methods. But at the end of it, what we're trying to do is learn something about the world around us, about the populations around us, and oftentimes we're doing so by applying just a sample from a smaller group than the whole population. Okay, and so there's a lot of reasons for that. We turn to sampling for a variety of reasons. It's often easier, and by that I mean cheaper or less time consuming, right? To sample a whole huge population of 1 million people or 330 million people is incredibly cumbersome, and so a lot of times we can get pretty good insight into the population by just sampling, a few thousand or a few hundred people. And we'll walk through some of those examples. For instance, even if we were interested in the population of our class, maybe there's 36 of us. Of course, we could probably, find all 36 of us and get that information. But we'll see, as even if we do something like a sample of 6 or 10 people, we can be pretty sure about what the actual population value is. Maybe we're thinking about the height of our class or the GPA, high school GPA or something. We can get pretty good insight with a small sample, and we'll talk about how sure we can be. Okay, so that's another big aspect of sampling and applying it to the population. We know we're not going to be exactly right. And so we'll build in not just here's our best guess, but here's kind of the range in which we think the population might fall, or how certain we are that we have the population value in this range. So a lot of times we do it for sake of ease, or time or money. Sometimes we have to take a sample because the nature of doing the test destroys the thing, right? So, of course, not in, when we think about populations as U.S. people or something, but what if you are a tire manufacturer and you want to test your tires, right? So, I don't know if it's required or what, but to get a certain rating on your tires, you probably need to set it up on a treadmill of sorts and have that tire spin for 60,000 miles and make sure it doesn't fail or what percent fail. Okay, so the process of going through that obviously destroys or makes not useful anymore the tire. So you can't do it for every tire that comes off the line, and so you may do it for every 1,000th tire or every 10,000th tire might get pulled out and driven. So that's another reason to go to sampling, because you would have no products left to sell. Okay, so when we think about sampling, at the start of chapter 8 here, we're talking through a few different types of sampling, and some of the issues that they address. Okay, so there are some problems you might face when you try to sample a population, depending on the population. And there are certain techniques that kind of get around those issues or deal with those issues, right? So, and we'll learn a few of these in this chapter. what I want you to take away from this is that so these are some of the more used techniques, but I want you to understand that there are a lot of techniques that can be used because there are a lot of little problems that could arise when you think about sampling from a population, and those are going to be pretty specific to the nature of the population that you're trying to draw from. And so there's kind of a whole subfield of inferential statistics that deals with how do we sample correctly and put the proper weights on things. Once we kind of talk about this in Chapter 8, a lot of the rest of the semester, we're going to just kind of be, loose with that and say, all right, let's assume that we've done the sampling correct. Now let's focus on the methods. And the reason for that is that we're going to have our hands full just learning the methods, the math, the intuition as to what we're trying to do here. So we kind of set aside the sampling issue and say, we've taken a good sample. We know how to do it. Okay, let's come and tackle the problem with that a given. But I do think it's important to remember that this is carrying with it some pretty strong assumptions, and namely that we've done the sampling correctly. So when you finish up this class and you go and read some news articles or look into a scientific paper or read some new COVID study that's coming out, it is important, and one of the things that statisticians do when they examine those types of papers is spend a lot of time thinking about, okay, have they done the sampling correctly? Can we assume that whatever they find here is relevant to the population? So this isn't a trivial matter. It's just that we're not going to spend a lot of time on it the rest of the semester. With that said, let's talk a little bit about sampling and what it means and kind of try to wrap our heads around what is a good sample. At the base level, a good sample, or the most straightforward one, is what we call a simple random sample. And if possible, that's what we go with. Okay, and you've probably done this many times, growing up in grade school. Okay, we got to select, 5 kids to, go in front of the school. I don't know. And all we do is we put your numbers in a hat, right? Everybody's got a number 1 through 200, whoever's in your class, and you pull out 5 random numbers. Okay, that's at the core of it. That's a simple random sampling. And the key here is that everyone has an equal chance to be selected. Every member of the population, whether we're talking about people or ducks or households or whatever we're talking about, each unit within the population has an equal chance of being selected into the sample. Of course, many won't be selected, right? We're oftentimes with sampling, we may only be taking, 100 people out of the 10,000. But each of those 10,000 in the population has the equal chance of being selected. And that carries with it very clean, good properties when we turn to applying that sample. So another way to conceptualize that, and I'm going to steal an analogy from Charles Whelan. If you've ever come across the Naked series, he has Naked Econometrics, Naked Economics, Naked Money, Naked Statistics. They're very good intuition. So I'm going to steal a concept or analogy from him, and that is of soup. So imagine we've made this nice homemade soup, a big vat of it, and one of the things that you do when you are, maybe it's got those handles, trying to figure out how to make this look more like a soup. Okay, so one of the things you got to do is you got to test if it's got enough salt or enough flavoring, right, enough seasoning. And the way we do that is we take a little spoon, right, and we dip it in there. But what we need to make sure we've done is we need to have stirred this, right? If we got a bigger spoon and we're going to stir this up, okay? I don't know if that was helpful. We need to stir it up because let's say we've just added in some salt and then we go and take a spoon and taste it. Of course, it's going to taste like it's got too much salt. And that's because we didn't randomly sample. We need this well mixed, and so that's what the simple random sampling is doing. We want to make sure that hat with all of our numbers in is well mixed, okay? If it's not, then we don't have that equal chance of being selected. So we dip the spoon in, we take a taste, maybe take a couple if it tastes really good, why not? But we take a sample, and we can get a good sense as to the salinity of the soup, because if it's well mixed, we get a little bit of kind of everything, or the salt is evenly spread out. So that's at the base of it, the simple random sampling. Now, why do we have all these other types of sampling? And in the book, I think we go through 3 other ones. Why do we have those? Well, let's think more about the soup. What if, maybe it's a vegetable stew or vegetable soup. You may be concerned that you're not getting a taste of some of the vegetables that are in there. And so you might go through the process of, yes, you're stirring it up, but as you take the spoon, maybe you take a spoon of the broth and then you take one of the carrots out just to make sure if it's done. So we can alter our sampling methods to address some of those issues. So for instance, in your book goes through things like the stratified random sampling or cluster sampling. Those types of methods deal with some of these types of issues where we need to make sure that we have at least sampled a little bit from some subgroups within the population. And so again, and that might be, maybe there's some certain, a small group within the larger population. So large companies, or I think in the book they talk about well-performing companies, and you want to make sure that your sample includes at least a little bit of there. So you might break apart the overall population and then take samples within kind of each strata of the population. And that's, in some sense, you can think about it as terms of different parts of the soup. You want to make sure you get a little bit from each. Now, a lot of times simple random sampling can be relied upon to adequately deal with that, but there are certain instances where we need to go a little different route, and that's why some of these other methods pop up. The other big area of why simple random sampling may not work is, in this case, we know the whole population. The whole population is the soup, okay? And that's often the case, but for instance, the truck or the tires, right? So the tires, we don't have the full population. The tires aren't done being produced. You don't actually know how many you're going to produce, or you don't have them ready to take the randomness from. And so there you may rely upon something like systematic random sampling, where it's still random. Everything that comes off the population has an equal chance, but the process is different. So for instance, you may, like we said, you're going to sample every 10,000th tire that comes off. And so you take one tire and then you wait for, tire 10,001 to be the next one that you take off, and then 20,001. Okay, so the process isn't quite the same, but we still get a random selection of the items. And so, yeah, again, at the end of the day here, what I hope you understand is that we're looking to kind of mimic simple random sampling. Even in cases where we can't exactly do that, we look for methods that approach that or get us close to those types of results. And then, again, largely after this kind of discussion in Chapter 8, we'll set aside those issues and just say, kind of for sake of ease, that we have done the sampling well. But I do want you to, at least when you leave the class, to have learned that there are issues in sampling and to be aware of those. And you'll, again, thinking about where we are right now with COVID studies coming out, we'll talk about how we can test vaccines using some of our methods here in the next few chapters. But part of that is talking about how well the sample matches the population. So these concepts in Chapter 8 are directly applicable to that.